Sir, am I audible?
Sir, am I audible? Sir, am I audible? Sir, am I audible?
Yes, sir, Giri, sir.
Sir, am I audible?
And yes, you
Hello?
are audible. Ma'am.
Okay, ma'am.
Nima ma'am, am I audible?
Audible, ma'am.
Okay, ma'am.
I'm
Thank you.
audible.
Thank you. Thank you, ma'am.
ఎక్కడ నేను చూడలేదు.
हाँ मैडम। हाँ
అలా అప్పారా గారిని కూడా అప్పారా గారిని కూడా అలాగే
అన్మ్యూట్ చేసి మాట్లాడచ్చు. A very good evening to one and all. Am I audible?
Yes, I can hear you.
Okay, sir. A very good evening to one and all. I, Dr. Arunima Mahapatra, Associate Professor, gives me immense pleasure to welcome you all to the inaugural function of our AICT ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. On behalf of our institution, I extend a warm and a hearty welcome to our esteemed Chief Guest, Professor G. Apparao sir, Professor of Civil Engineering, IIT Madras, a renowned academician and researcher whose presence truly enriches this program. I also extend my sincere welcome to our respected principal, Professor D. Deepak Chaudhary, our head of the department and convener, Professor G. Tirupati Naidu, and our chief guest and guest of honor, Dr. G. Madhukumar, secretary and correspondent, for their constant support and encouragement. A warm welcome to all our faculty participants, resource persons, research scholars, and industry persons who have joined us from different institutions across the country. Your active participation will surely make this FDP a fruitful and engaging learning experience. This 6-day program is designed to explore the latest innovation and sustainable practices in civil engineering, aiming to promote eco-friendly and resilient construction. I hope all of us will benefit immensely from the session and discussion ahead. Once again, I welcome you all and wish the program a grand success. Thank you. To invoke the divine blessing for the success of this program, let us begin with a short prayer.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि.
Now I request our beloved principal, Professor D. Deepak Chaudhary, to deliver the opening remarks and share his thoughts. Over to you, sir.
Thank you, Dr. Arunima. Honorable Secretary and Correspondent of Dr. Lankpal Bulaya Colleges, Dr. G. Madhukumar Garu. Today's Chief Guest, Professor G. Apparao Garu, Professor IIT Madras. Head of the Department of Civil Engineering, Dr. G.T. Naidu Garu. Faculty of Civil Engineering Department, participants of this FDP program, good evening one and all. First and foremost, I would like to congratulate the Department of Civil Engineering for applying for this ACTE Training and Learning Faculty Development Program and successfully getting the acceptance from ACTE for conducting this 6-day faculty development program on sustainable practices and innovative trends in civil engineering. And I would also like to take this opportunity to thank the ACT for giving the this opportunity to Dr. Lankpal Bulaya College of Engineering. And to all the participants, as a teachers, we all know that how the technology is evolving now and how AI is playing a main role, and how the students, as a teachers, we are coming across different situations where the students are getting aware of how to utilize this AI day by day. But from technical perspective, if we don't understand completely about the fundamentals, concepts of any technical concept, we cannot evaluate whether the AI is giving the correct output or not. So in this aspect, most of the researchers now are also using AI, but to what extent the outcome of that particular AI can be used is a big question mark, and it's a debatable question. And another important aspect that most of the teachers are facing is usually teachers who are having relatively less experience in some concepts while explaining to the students, they feel difficulty in how to reach that particular concept to the student. So by listening to learned resource persons and from experienced teachers, the young faculty can explore the different ways of taking the fundamental concepts to the students. So one aspect, exploring the knowledge in the latest developments in civil engineering in this particular through this FDP program. And the next thing is by listening to the learned resource persons, the upcoming teachers, even the experienced teachers also can get different ideas of how to make the concepts understand to the students in classroom teaching. So in these two aspects, I am 100% sure that this FDP will be useful for all the participants who are participating from different parts of the country. And I wish all the success to the Department of Civil Engineering. And I also take this opportunity for conveying my heartfelt thanks to Professor G. Apparao Garu for accepting our invitation to act as chief guest, also to act as a resource person to share his knowledge through this particular platform. Once again, all the best to the Civil Engineering Department and all the participants. I hope that you will utilize this opportunity for sharing your thoughts and also understanding the different aspects of recent trends in the development in civil engineering. Thank you. Thank you, one and all.
Thank you very much, sir, for your inspiring words and thoughtful insights. Your constant encouragement truly motivates us to continue our academic journey with renewed enthusiasm and purpose. Next, I invite Professor G. Tirupati Naidu, Head of the Department and Convener of this FDP, to share his remarks and vision for the program. Over to you, sir.
Good evening to all. It gives me immense pleasure to welcome you all to this faculty development program on sustainable practices and innovative trends in civil engineering. I, Dr. G.T. Naidu, Head of the Department, on behalf of the Department of Civil Engineering, Dr. Lankapalli Bolle College of Engineering, Visakhapatnam, I extend a warm welcome to our chief guest, Professor G. Apparao Garu, Professor IIT Madras, our guest of honor, Dr. G. Madhukumar Garu, Secretary and Correspondent, Lankapalli Bolle Colleges, our respected Principal, Professor D. Deepak Chaudhary Garu, colleague heads of the Department of Dr. L.B. College of Engineering, esteemed research persons, faculty colleagues, and participants from various institutions. Civil engineering, as we all know, is one of the oldest and most essential branches of engineering, shaping the very foundation of human civilization. Yet, in today's rapidly changing world, our responsibility as engineers extends far beyond design and construction. We are now the custodians of the environment, stewards of sustainability, and innovators driving the next generation of infrastructure solutions. The theme of this FDP, sustainable practices and innovative trends, is both timely and relevant. Climate change, resource depletion, and urbanization demand that we rethink the way we build. Sustainable engineering is no longer an option, but it is a necessity. From the use of green materials and energy efficient designs to smart technologies and digital construction methods such as BIM, IoT, and artificial intelligence. Innovation is redefining the way we are approaching the civil engineering. This program aims to create a platform for sharing knowledge, exploring new ideas, and encouraging collaborative research among faculty members. Over the next few days, we will have the opportunity to interact with eminent experts, researchers, and industry professionals who will share their valuable insights and practical experiences. I am confident that these sessions will enrich our understanding and help us integrating sustainable and innovative concepts into our teaching and research practices. I take this opportunity to thank the organizing committee, Dr. Arunima Mahapatra, coordinator, and Mrs. B. Ramya, co-coordinator of the ATAL FDP, and the faculty members of the civil department for their dedicated efforts in planning and coordinating this program. My sincere appreciation also goes to AACT and the management of our institution for their continuous support in making this effort, FDP, possible. I am delighted to share that around 316 participants from more than 185 institutions across India have registered for this program, which reflects the growing interest and importance of sustainable and innovative practices in civil engineering. I am happy to inform that we have 13 resource persons, 6 from academic institutions like IIT, NIT, university within India and abroad, and 7 from industrial background. Let us all participate actively, exchange ideas freely, and make the most of this academic gathering. Together, let us commit ourselves to build a future where development and sustainability go hand in hand. Once again, I welcome you all and wish this faculty development program great success. Thank you very much. Back to Arunima.
Thank you, sir, for your valuable words and for inspiring us with your vision and guidance. The message reinforces our collective commitment to excellence in teaching and research. We are honored to have with us Dr. G. Madhukumar, Secretary and Correspondent. I now request Sir to deliver his address as a guest of honor. Over to you, sir.
Thank you, Arunima. Good evening, everyone. It's indeed a happy thing to see self-improvement programs, faculty organizing things for themselves, and ACT supporting this. To begin with, I would like to thank Professor Apparao Garu, who has been constantly supporting our college in previous meets and now. So thank you very much for being able to give your time and attention to our college. Thank you. And my good friend, Professor Balaji, I don't know if he's online or not, but I would also like to thank him. And several other resource persons from various universities, NITs, and people who are practicing civil engineering, both from here and abroad. Thank you all for taking out your time and energy and being patient to be able to connect to us. Thank you. And I'm happy to note that more than 300 participants from all across India have registered. It's a great scope for all of us to discuss. The very title itself, Sustainable Practices and Innovative Trends, not necessarily in civil engineering, but this is a requirement probably across every aspect of our life now. With AI and related technologies threatening our very own existence and importance, perhaps for the good or for the worse, we don't know. But at the moment, we are going through a churn. Computer sciences have introduced a lot of convenience, but also have given a lot of difficulty for core engineering courses, wherein our own sustainability as a civil engineer, chemical engineer, mechanical engineer is under question. And I see that increasingly people have taken to computer science, even from these disciplines. So how do we actually supply people at the highest level of practice to be able to take care of each engineering with its own importance? That's one aspect. The other part, as applicable to India, while we have achieved great strides in terms of being able to construct things, for example, what we've done in Kashmir and the upper levels of India to be able to construct metros and things like that. So on one hand, the demonstration of our ability in technology at the highest level. On another hand, continuously falling bridges which have been constructed recently probably has to make us think this whole ecosystem of management, politics, and applicability of various practices that we have is not necessarily the design or engineering principles that are at stake, but the very way we are organized as a society, what importance do we give to our infrastructure, quality, etc. It's all under question. It's easy, for example, to see civil engineering because it's there right in front of our eyes. And many times, there was a time when people were important in civil engineering, continue to be important, but with this difficulty in terms of society's priorities today, how do we get it back? In my opinion, every one of us who is actually in this practice of civil engineering, electrical engineering, whatever engineering that we choose, we probably have to think that we have to be the best and to be able to understand what is going on in the world at the highest level and the cutting edge. With that and continuously learning practices, it's a challenge for all of us. I am also distressed to note there are many students who are now lost in social media and then probably other priorities that they have. Their ability to focus in the 4 years that they have with us as engineers and research atmosphere, the ecosystem, not really perfect. With that, our ability to contribute at a higher level is constantly under threat. The only way for us to do is to sort of completely dedicate ourselves by realizing what is the scope and our objective in this field, and to be able to do the best, both as an individual and as a group. Now, this is where I suppose, and as a general management person, I can say is a crisis practically across all sorts of things that we do. And civil engineering has a tremendous scope to improve our own way of doing things. As you can see, there's still a lot of big cities having issues with road infrastructure, bridges infrastructure. It's nothing to do with the civil engineering practice, but more to do with this compendium of ecosystem, which takes care of both the political decision making, the executive authority, and finally the contractors. This whole system has built-in inefficiencies. How do we address this is one aspect. The other thing is, how do we continuously keep up at the highest level? Can we actually do anything about it? And Hyderabad, for example, which has been at the forefront of being able to develop the infrastructure, which is successful partially, but failing partially. This gives us that direct requirement of being able to do something more, both in the management, design, execution, maintenance, the whole works. So from that point of view, I think it is a good practice for all of us to share our experiences. And faculty members, generally speaking, most of us in colleges or universities tend to be secluded in our own circle. Probably we do all right by taking care of the syllabus, preparing people for examinations. But our own self-development, our own ability to go to the highest level is under threat. So therefore, my request to all the faculty who are participating, open up your minds. There is nothing that cannot be achieved if we open up and spend a little time every day. And things like these give you an opportunity to actually listen to great people. And my request to you is please interact. Try to take something out of this so that this can actually be sustained in a positive way. God bless you all. Thank you all for participating. And I wish this seminar a grand success. And I thank our own team, the principal, Dr. Deepak Chaudhary, and Dr. G.T. Naidu, Head of the Department, Dr. Arunima and her team for organizing a great show. May God bless you all to make sure that this becomes a tremendous success. Thank you.
Thank you, sir, for those encouraging and motivating words. Your support adds great strength to every academic initiative we undertake. It's now my pleasure to introduce our distinguished chief guest for the evening. I invite Mrs. M. Himangeshwari, Assistant Professor, to present a brief introduction of the chief guest. Over to you, ma'am.
Thank you, ma'am. Good evening, everyone. It gives me immense pleasure and honor to introduce our eminent guest and today's speaker, Dr. G. Apparao, Professor of Civil Engineering at the Indian Institute of Technology, Madras. Dr. Apparao is one of India's leading academicians and researchers in the field of structural and concrete engineering with an illustrious career spanning more than 3 decades. He obtained his BE in Civil Engineering from Andhra University, ME and PhD from the prestigious Indian Institute of Science, Bangalore, and later completed his postdoctoral fellowship at the University of Stuttgart, Germany, under the renowned Alexander von Humboldt Fellowship. At IIT Madras, Dr. Rao has played a crucial role in advancing research in fracture mechanics, high performance concrete, precast structural systems, and seismic strengthening techniques. He has successfully guided more than 18 PhD scholars, numerous MTech and MS students, and has completed several sponsored research projects from premier organizations including DAE, DST, and DRDO. His contributions have been recognized with several national and international honors such as DAE SRC Outstanding Investigator Award, the Bharat Vikas Award, and the Dr. APJ Abdul Kalam Life Achievement Award. Dr. Rao is also a life member of esteemed professional bodies like American Concrete Institute, Indian Concrete Institute, and the Alexander von Humboldt Foundation. In addition to his research achievements, Dr. Apparao is an inspiring teacher, mentor, and leader who has delivered over 90 keynote and invited lectures across the globe, including in USA, Germany, France, Korea, and Austria, sharing his expertise and passion for innovation in civil and structural engineering. We are truly honored to have such an esteemed professor with us today. On behalf of the organizers, faculty, I extend a warm welcome to Dr. G. Apparao, and we look forward to hearing his insightful address on the latest innovations in concrete and structural engineering. Thank you so much, sir. Over to Dr. Arnima, ma'am.
Thank you, ma'am, for the wonderful introduction and for highlighting the remarkable achievements of our chief guest. Your words set the perfect context for the session. We are privileged to have with us Mr. G. Apparao, Sir, Professor of Civil Engineering, IIT Madras. I now request our chief guest to kindly deliver his inaugural message. Over to you, sir.
Yeah, very good evening. Are you able to hear me?
Yes, sir.
Yes, sir. Audible, sir.
Yeah. Okay, very good evening. So, thank you for the invitation from the organizers, Dr. Lankapalli Bullaya College of Engineering, Visakhapatnam, and the other members who spoke before me, and invitation from the principal and the head of the department and other faculty members. I'm very glad to be here and to stand before you to speak something about the faculty development program. But one thing about the faculty development program or short-term course is an intensive course planned to give, like, instead of 1 year, it's like in 1 week or 10 days. It's learning expertise or related to civil engineering. So if you see the members involved in delivering the expertise lectures, it's overwhelming actually. It's the hard work done by the organizers, in fact, and for the young engineers, researchers, or faculty members who are in the presentation or in the meeting. I think it's a great chance for all of you because planning is one thing, getting acceptance is important, and getting the financial support and administrative support, it is something, hard work actually done by the people. And also, one thing I would like to emphasize is the experts, they learn or earn over 30, 40 years throughout their life. And they're going to deliver their expertise in 30 minutes. There's an immense experience that is being poured now. It's very a great chance for the young engineers to learn something new for them to grow in future. It's important actually, because actually every big company or every organization, they're claiming that we are not getting the qualified civil engineers. It's very unfortunate to get that word from people, but actually despite the fact that 90% of the infrastructure is being developed by civil engineers. And we spent about 75% of the GDP. India's, okay, the whole money will be spent by civil engineers on all civil engineering projects. It's a huge actually. So actually people claim that then the job chances are very, very meager. It's not so. The qualified people, knowledgeable people, definitely there is a way, there is a chance for them to be, okay, invited by any company or accepted. That's what actually, even I tell my students that you do whatever you do, whatever you are in present. So definitely, it's not that civil engineering doesn't have any chances. Okay, there's a big scope for civil engineering also. But the only thing is, how do you plan yourself? It's important. So these programs, these platforms or venues are very, very useful for the young faculty, young generation to make themselves, okay, to mold themselves, to direct themselves into the right direction. You don't get the chances to do so. It's not easy, in fact. So I advise all of you, please go through, because in civil engineering, not only the construction, any basic civil engineer, the man who learned as a civil engineer is good enough, actually follow the codes and other standards to ensure the safety. Ensuring the safety is one aspect, serviceability, but in the end, overall economy means even including the life of the people living in that structural system. So it's very important for us to understand these things. And of course, time to time, materials, innovation, technology, there is a scope. There is a big scope actually. Time to time, we change everything. 20 years back, civil engineering was different. Now the present civil engineering is entirely different. All mega structures are being constructed. All challenging tasks are being, okay, accepted, taken by the civil engineer. I tell one example where actually the well foundation was sinking because of this like a clay soil. It's a dangerous soil. So actually the soil mechanics, okay, experts, they could sustain, they could support that, retain the sinking. It is something, you know, all these short-term courses, like, you know, specialized topics will be very, very helpful. There are so many materials, construction practices, okay, even other research you can take related to extreme loads. You can take earthquake loads or you can take impact loads, okay. These are all the cases where actually not much work has been done. Okay, so maybe code provisions are there, but still they require a lot of refinement. The contribution from the young generation, young engineers, young researchers is a huge. It is required, again, you know, it's a quality output is important. Not the output, whatever you say, it's fine. No, it has to be accepted by the national, international, okay, I mean, experts. And hence you can think about publishing, you can think about writing, and you can demonstrate the engineers. It is required actually, finally, to go to the code provision. Whatever you do in your lab, okay, whatever I do in my lab, everything to be published, that will be accepted and finally discussed and the core committee will come out with some kind of conclusion. That is what actually you be helpful to this society. All your short-term courses, all these platforms, definitely for you is a foundation. And you start with this one, you can grow, you can after 10 years you plan what I would like to become. Definitely for the young faculty, young engineers, is like aiming at say PhD. Identify a topic of your interest, you can work seriously, then again seriously you can develop something and then go ahead. And finally, after 10 years, you be a resource person. You be helpful to the society. Finally, all your standards and code provisions will be developed. Okay, in fact, your contribution. So all the speakers actually invited by the department, I think they have a lot of experience over like 20, 30, 40 years of their expertise. And I hope this program will be immense help for the young faculty particularly and the practicing engineers something ideas. Actually, I also involved in many challenging projects where actually something structures are being failed due to some inefficient design, or it is a kind of non-application of basic civil engineering. So when actually you are a civil engineer and you are just stick to the fundamentals and no structure will fail. And you are say so-called engineer or a researcher, when you make something, erroneous output, and somebody uses that, like say invention of a new material, new technique, and all these new things will be sometimes unknowingly advantageous, but sometimes very dangerous. And hence it's always to have a kind of experimental or some kind of numerical investigation to understand those techniques or materials, whatever. So innovation, always something new to be come out. This is what actually the platform over next 1 week or say 10 days. I think all the deliberations and the demonstrations, expertise from people will be very, very useful. And the hard work done by the department and the organizers, I hope after 6 days, I think the people will find themselves very confident, something they can do in future, next 3 years or 4 years. That is what these short-term courses actually meant. You can improve your qualification, you can improve maybe your understanding, knowledge in which you would like to grow or just progress. That is okay. All these programs are meant for that. This is what actually inviting experts, the government of India or even college, they spend a lot of money for this purpose. And this is for our purpose, for the societal needs. So I advise the young faculty, young scientists, engineers to be serious about these programs and learn and earn. And you can also be an expert or be useful to the society. And in fact, I have organized many conferences, many seminars, and it's very tough job to organize these things. You spend a lot of money, a lot of time, the whole administration behind, and of course, and inviting the experts. Not easy to get all these things. So it's ready to get something, grasp the information that is being delivered on one platform from the experts earn 30 years, 40 years in 30 minutes. And I hope this program be a grand success after 6 days. I hope everything will run smoothly. And once again, I congratulate the organizers identifying an important topic, because sustainability is important. Always you have to live, you have to let live the system. There is a whole thing with the new things, with the new techniques, everything developing, progressing, but it's sustainability. And I think actually this will be a grand success. And I congratulate the organizers and also thank the organizers for inviting me to be a part of this program, just to start with the program. And I wish the organizers very best of luck for the next 1 week. And I wish the young engineers to be enriched with the knowledge gained by the expertise. Thank you so much and all the best.
Thank you very much, sir, for your motivating and insightful address. Your words have truly inspired us to pursue innovation and excellence in our professional journey. To formally conclude this inaugural session, I now invite Dr. G. Giridhar, Associate Professor, to deliver the vote of thanks. Over to you, sir.
Thank you, Arnima Madam. Good evening to each and every participant and the dignitaries who present here. I express my sincere gratitude to everyone who contributed to the successful inauguration of our 6-day online ATAL faculty development program on sustainable practices and innovative trends in civil engineering. First, I extend my heartfelt thanks to our chief guest, Professor G. Apparao Garu, Professor of Civil Engineering, IIT Madras, for delivering an insightful and inspiring message. Your expertise and guidance have added great value to this program and will certainly motivate every participant. I express deep gratitude to our guest of honor, Dr. G. Madhukumar Garu, Secretary and Correspondent, Dr. Lankapalli Bullaya Colleges, for your encouraging words and for your continuous support toward academic and research initiatives. My respectful thanks to our President of the function, Professor D. Deepak Chaudhary Garu, Principal, Dr. Lankapalli Bullaya College of Engineering, for your opening remarks and for always encouraging departments to take up such meaningful academic activities. I extend special thanks to our convener, Professor G. Tirupati Naidu Garu, Head of the Department of Civil Engineering, for leading this program with vision and commitment. I also appreciate the efforts of our co-coordinator, Mrs. B. Ramya Madam, and coordinator, Dr. Arunima M., for their meticulous planning, arrangements, and support in organizing this FDP. My sincere thanks to all faculty members, organizing committee members, and technical staff for ensuring smooth coordination of this inaugural event. I also thank all the participants for joining this FDP. Your involvement and enthusiasm make this event purposeful. Finally, I thank each and everyone present here for contributing to the success of today's inauguration. Thank you once again for giving this opportunity. Over to Arnima Madam. Thank you, ma'am.
Thank you, sir. Thank you to all our dignitaries for the inspiring words and for gracing the inaugural session. I now request all the participants to disable the videos so that we can take a screenshot of the inaugural session.
Thank you. I take leave then. Yeah. Thank you. All the best to you people.
Thank you, sir. Now, as we move from the inaugural to the technical proceedings of the day, it's time to begin our first expert session of the ALCTE ATAL Faculty Development Program on the sustainable practices and innovative trends in civil engineering. We are truly honored to have with us Professor G. Apparao, sir, Professor of IIT Madras, a renowned expert in structural engineering. Sir, we are delighted to have you here to share your insights on the topic behavior of RC special elements under extreme loading conditions. Now I take great pleasure in handing over the session to you. Sir, enlighten us with your valuable lecture. Over to you, sir.
Are you able to see the screen?
Yes, sir.
Okay. Yeah. Okay, I would like to speak on special concrete elements. So I have actually planned to talk about something special elements, for example, is not the conventional elements like deep beam, shear wall, then beam column joints, and something related to research to come out with innovative ideas to test them, to fail in the required mode. Once again, good evening and welcome you all for the presentation. So once again, I thank the organizers for giving me the chance to present my findings. The work involves a lot of other projects also. So consultancy or research or even interaction with other members in various fields. And I talk something related to concrete, okay, a constant material. Interface in concrete is very important, and cement grout related to precast construction. Something briefing segmental construction advantages and challenges, and the transportation system, bridge system, and whether it is a reinforced concrete system or pre-stressing system, but the cyclic bond in the case of rebars embedded in concrete. And the direct shear test for calculating or determining the toughness of material, concrete, are incorporated with various other ingredients. And the behavior of precast elements, shear walls, and beam column joints at the end, and under earthquake loading and so. Understanding the concrete actually. So it looks like a old system, and we have been just reading here and there, and then somebody is talking about this. But actually now if you look into the constant material, the basic forms are like cement for binding purpose, and sand and coarse aggregate for like filling the volume, and water for reaction with the cement. So cement paste binds all the inert material. That was the concept or the idea of using cement, water, and embedding all the large size particles. Now actually along with we come across voids, defects, vacancies, micro crack, interfaces. And when you add something to change the characteristics in the early stages, like workability, compactness, microstructure, say high performance concrete, some kind of thing, like our special material. This is very important for the engineer. These are all the things are going to happen. These are the things happening parallelly when you are going to manufacture or produce concrete. So each one of them will be a challenge. When you look into the individual things, a great study needs to be undertaken. So it's not just like one thing, because nowadays we find a lot of innovations in the material technology. Actually, whenever you use the secondary product, byproducts, along with cement, due to some advantages or some kind of performance related characterization. So there actually you identify the material, and cement is replaced partly by this so-called byproduct or industrial byproduct. Now actually cement itself naturally it reacts with water, only cement, CaO. So that is what actually calcium oxide will be reacting with the H2O. That you will give some kind of output. And actually, when you see this is the basic reaction that is happening, Portland cement and water. And the basic form or the major part of the reaction product is calcium hydroxide. Calcium hydroxide about 30 to 35%, which is in the hardened state after reaction complete. That is actually, it's very, very vulnerable and weak and brittle. And that is vulnerable against the chemical impact also. So that is actually, weak product needs to be reproduced. Like, a kind of different calcium silicate hydride. So here the basic form, equation number 1. So you get a calcium silicate hydride is a basic form, which is not so strong, because olden days we never thought of the influence of water. Okay, but actually it has a significant role to have a lot of calcium hydroxide. That is not acceptable, not advantageous. Now actually whenever a part of the cement is replaced with say pozzolanic material like a silica fume you take, flash you take, GGBS you take, anything, because a lot of research is being done. Now this calcium hydroxide after CaO plus H2O and whatever the pozzolanic material, it has its own composition. In that Al2O3, then SiO2 and all the particular SiO2. SiO2 reacting with the calcium hydroxide CaOH twice. So that is what actually the SiO2 present in the pozzolanic material is not reactive on its own. But in the presence of cement, water, and SiO2 will have something different. So calcium silicate hydrogel will be formed, is a different form. So there actually in the equation number 2 or equation number 3, you find different C3H2H3, that is a calcium silicate hydride. That is the one actually going to change the internal structure, the performance of concrete, because the inert materials, so they will not participate except filling the volume. The one actually calcium hydroxide plus SiO2, you will get a kind of C3H2H3. That is the one, whether it is a stronger one or just a weaker one, that will decide the final product. Concrete, whether it is a high performance concrete or high strength concrete, in which the interface type is very important. The type of interface, that means the calcium hydroxide plus, okay, whatever, SiO2, that is a small layer formed around the coarse aggregate or fine aggregate. It is called the interface. In ordinary concretes, without any industrial byproduct, a lot of water will be stagnated. It will be expelled after drying shrinkage, okay, or whatever. And that leaves the gap, that leaves the voids. Those voids are not advantageous for us, strength-wise or the durability-wise. And hence, the pore size structure, when you have the byproducts combined with calcium hydroxide, will make the structure very, very microscopically very impervious. So that actually leads to a small interface or with a very impervious interface and with very strong characteristic. That changes the whole, okay, concept of this technology, concrete technology. That actually changes everything. Whether the concrete exposed to aggressive environment is durable or the strength of the concrete is very high. So this is something, we have the inert material, and along this wall, or say just on the surface of the aggregate, a very thin layer formed in nanometers. So very, very small. That is actually, that changes the whole idea, interface. And okay, there is a transition zone. The transition zone and its microstructure. So having, okay, calcium hydroxide layer, but actually that will be reacting with SiO2, changing something, a very better layer. Actually, this process, okay, can be described. There is a pore size refinement and matrix densification. When the secondary materials, byproducts are added with, okay, cement plus water, or say in general calcium hydroxide. Calcium hydroxide reacts with SiO2 present in the byproducts. So there is a pore size refinement and a densification of the matrix in and around the aggregate. That is called interface. And also calcium hydroxide is being reacted with SiO2. So the quantum of calcium hydroxide will be consumed or reacted with, okay, SiO2. So that changes a very stronger calcium silicate hydride. And the cement paste aggregate interfacial zone refinement. So there is overall refinement, betterment. So these three reasons are responsible for a very strong interface, durable interface, impervious, okay, interface. That actually the whole idea. So one has to be very, understand what exactly happening. What is the fly ash chemical composition, silica fume composition, or GG-based composition? With the basic equations you combine, come out with a chemistry that demonstrate well about the reality of the reaction happening. That is one thing. And now actually, all your primary girders are being precast. Okay, so when you have the precast system, that's fine. And the deck slab will be constructed at cast in situ. So the precast elements and the cast in situ elements will be integrated. Maybe reinforcement may be that we can integrate. But now all your precast elements like beams you have, columns you have, slabs you have, all elements, whatever the form, reinforcement, detailing, everything can be made it ready to use for your structural application. So there actually joining is important, connecting the members, different precast members with a stronger element, that is anchors is important. Anchoring is important and binding material is important. So when the mass of the, volume of the gaps to be closed, and there actually cement grout will be used. When just only sticking the two surfaces, maybe resins can be used. So depending upon the volume of gap to be closed, so if the volume is significantly larger, you have to think about the cement grout. In the market, the cement grouts are available in like 25 kilograms. So that is actually advantage of these things will be in one day, they could achieve you 50 newtons per mm square, 24-hour strength. That is the advantage. So you can have the formwork overnight, you can complete the process, and the next day you can remove the scaffolding system. So there actually important thing, the grouting material, because it has to occupy the each and every corner. It has to surface the, surface of the rebar. So then actually the grout to be used in a gap between two stronger elements. So no creation of separation, no gap should be created. Bleeding segregation should be avoided. And shrinking of the grout should be minimum, no shrinking at all. And sufficient strength after hardening. And when you ever use this one, it should reflect the original characteristics of the structural component, no detrimental effect. And of course, durable as the precast element. So therefore, all these characteristics can be achievable using cement grout. Now, actually, all your precast segmental construction being used this cement grout. It's very important. The source, the origin of this one, then the characteristics, all so to be understood. We have to investigate the behavior of these things, performance of this material in reality. So there are so many commercial products are available. It's a basic research needs to be carried out. So we have the standard codes of practice, you follow them, and it's a simple research. Whatever you demonstrate to the second year or third year BTech students, your concrete technology lab. Though it's a preliminary, it's characterization is very, very important. Though it looks like a routine, but actually understanding and maintaining record is very, very important. So in this process, a product is being identified and a very simple research has been conducted in the laboratory, a preliminary investigation, but the output is a huge advantage for the construction industry. Now actually in this process, actually to check its strength in the early stages, 1 day strength, 3 day strength, 7 day strength, like this. And of course, comparison of the cylinders and cubes also. Whatever we obtained and all those things were validated experimentally. So we have this one flexural tensile strength, in 1 day actually in 3 days 6.1. 7 days 9.2, 9.28 or something. It's a huge strength gain even in early stages. And the typical experiment actually one can do is this one tensile strength. It is actually cementitious product and a reduced cross section, but actually generating data for understanding the direct tensile strength of cement grout or cement. It's important. Briquettes are already known with a 25 by 25 cross section. It's a reduced cross section, and the setup is like this. One can fix this one using a displacement control system. One can know the strength in the early days. Is 1 day strength 2.2 newtons per mm square, 3 days strength 3.1 over 7 days, and 28 days itself it is 6.0. It's a huge strength development in cement grouts, and understanding that one and the pre-stressing operation can be initiated immediately, because the minimum tensile strength of concrete or cement product, whatever that is needed. So when these special products are being produced or used, one can achieve the required strength even in 3 days, and hence easy for the construction companies to complete their pre-stressing work and remove the supporting system, because already the grout has achieved its required strength within 24 hours. And this is actually the shear actually. This is also very important because all major constructions, all major structural components, some locations, the critical in shear. So there actually, wherever the shear critical zones, the cement, okay, cementitious product can be, okay, advantageously utilized. As routine test anyway splitting to understand its comparison with the direct tensile strength. It is the indirect tensile strength of concrete, but it is mostly about 2.5, okay, times that of the direct tensile strength. But it is a value for the engineers to understand. Now, whenever the precast system continuously exposed to environment, rainy seasons for 1 week, and you should be able to understand the absorbing capacity, water, because this gives you the durability of the product. Because the aim is to have for 100 years construction, I mean structural system. It has to be there for 100 years, not for 50 years. So in view of that one, this property is very important. And all your precast elements exposed or submerged in water, okay, they should not absorb water significantly. And this is another way of observing the quality. The quality of concrete can be prescribed by measuring the, okay, the waves passing through, pulse, okay, that is sound waves passing through concrete. That gives the density, that gives the quality of concrete. Whenever this product, okay, achieves 4.5 above, this is something, an excellent product to be used for your special construction practices. And whenever the flexural members and whenever we have the reinforcement bars in beams, flexural members, the end regions are very important. The end regions of the, okay, that is primary girders or deck slabs, whatever, they will be subjected to very high shear force. Whenever the shear force is high, that means it is a change in the bending moment. The change in the bending moment is very high. Then actually the rebars will be subjected to very high horizontal stress, that is bond stress. Sometimes if you don't provide sufficient anchorage length of the end regions of the rebars, beam bars, there is a possibility of pulling out of the bars from that. Particularly when you aim at the construction or the structural components to be last for 100 years, then actually you have to be very, very careful, because some regions, the end regions, are vulnerable for pulling out of the rebars. Particularly whenever there is a high shear force, and unless you provide sufficient anchorage length, not the development length plus additional, okay, extension, that is the anchorage length. Otherwise, because some cases where when the steel reinforcement bars on full tensile strength, when the stress in steel reaching its full tensile strength, and actually there is a possibility of pulling out. End region should be properly anchored. If you don't do that, the bars will be pulled out of that. So the anchorage bond in such cases will be significantly, I mean, important. So therefore, the strength of these cement grouts is under, say, static loading is fine. But actually all bridge structures will be experiencing variation in the loading. That means, okay, cyclic loading, fatigue loading. And due to that, sometimes the rebars will be under stress, and sometimes the rebars will be, okay, subjected to very high bond stress. Sometimes the accidental loads can also cause very high bond stress. When the bridge is designed for a particular, okay, defined load, and if there's a possibility of, okay, accidental load, then actually it may not fail, but actually in the long run, the life of the structure comes down. So this cyclic bond response is very, very important. No code provisions are available now, but actually it's a kind of accidental load. Bridge structures are experiencing very heavy loads. Maybe it's like a class A bridge, a class B bridge, or whatever. Sometimes the bridges are not meant for the higher loads, but they experience. That is nothing but the accidental load for that particular structure. So therefore, what will happen if a bridge structure subject to cyclic loading experiences an accidental load? What will be the line? From the studies, actually, so when there is an accidental load, actually the slip exceeds, okay, number of cycles, okay, applied, that is loading, unloading. and the slip significantly increased. That means the rebars are pulled out of concrete. And hence, actually, the number of loading, unloading cycles, okay, it may be failing suddenly due to accidental load. So this is that slip versus number of cycles. Slip actually gradually increasing with the number of cycles, but suddenly due to accidental loads, the slip, okay, failure, that is anchorage bars will be pulled out of. This way, actually, one can apply unloading and loading. Loading, unloading curves can be drawn by applying the number of loading, unloading cycles, and one can study the bond stress. That is one thing, actually. So what we found, the rebars, particularly in the precast system, flexural system, primary beams, or even deck slab, as like segmental construction, end regions are being provided with skin reinforcement or the stitch reinforcement, but due to the cyclic loading, they may experience a kind of, okay, bond fatigue. So therefore, there's a possibility of failure. And now, actually, important thing now, actually, whenever you look into the research, okay, all your concrete specimens, of course, a lot of laboratory studies, okay, need to be done. Now, actually, this aspect is, so not much information about shear failure. Flexural failures are very clear, majority of the, okay, activities or research, okay, activities. But actually, studies on mode 2 are, okay, that is a secondary, that is shear failure. Okay, because we don't find shear, what we don't flag for seriously, flexural movements are being taken as critical. Shear will be taken as secondary. But sometimes shear is predominant. So there actually we require the members which experience high shear force need to fail in ductile manner. So therefore, for that understanding, the specimens failing in shear, what will be the toughness? That is the energy absorption capacity, ductility of the system. So now actually in research, so there are some elements, okay, already somebody proposed over years, okay, 1967 itself, there is something, a specimen proposed. This is the one proposed by, okay, the researcher. This is called IOC Pescu. So the shear test. This is something. We have the notches and the support here and the support here. This actually, the idea is to shear off this cross section. But actually, they could not achieve the real shear failure. And again, later on, somebody changed the setup and this kind of setup, but still they could not achieve real shear failure. This is actually Bajan shear test, actually. But again, ideal shear failure was not achieved. Now, actually, then this is something. This is Japan Society of Civil Engineering. This is the basic form proposed by JSC. Okay, and actually this one also, this they propose to shear off the cross section, but it's a mixed mode, combination of flexure and shear. And now actually after understanding this one, a lot of papers are being verified, reviewed, and understanding the fracture mechanics, it is a specimen that is defined to define the failure plane. And this is the geometry adopted. This is the net cross section. All around we have the cross section, okay, notch. So there actually, now actually a special supporting system was invented, and we could achieve the direct shear. That is the direct shear failure here. This is the direct shear failure. There is nothing, there is no flexure failure, there is no mixed failure. So this is the special, a number of trials were made, finally we could achieve this one. Now this is something understanding the influence of randomly distributed fibers in plain concrete. This is actually because shear and also they are very vulnerable for brittle failure. To improve the ductility of the system in shear, direct shear, actually idea is to add some steel fibers, little fraction, very small quantity. So these different mixes have been proposed. Everything is same, only the fiber content was changed. That means 0 plain concrete, 0.5%, 1%, 1 by weight of, okay, concrete. So this way, actually, the energy absorption in mode 2 or shear failure, this is work of fracture to the uncracked, okay, ligament length. Otherwise, when you take the shear, that is plain strain case, this is something. This way, actually, the toughness of the concrete, okay, was investigated, and we found that as the fibers added to the concrete influences the failure mechanism and also shear strength. shear strength increases, and actually there is one index actually. The index is calculated as the area under the load. So as the number of fibers are added in concrete, then the ductility increases, and after the peak load, there is a descending curve, a long descending curve could be achieved, and from there, area under the load versus deflection curve up to 3 times that of the deflection at the straight line part. Okay, divided by, no, this delta is the deflection corresponding to the straight line part, roughly elastic. Okay, area up to that and up to 3 times delta. So there is a larger area up to 3 times delta divided by the area up to only delta. So that gives the idea how ductile the material is. So toughness index increases with increase in the volume of fibers. Okay, very lightly, not very significantly, but there is an improvement. Ductility increases are improved due to the addition of steel fiber. That is one thing. And nowadays, actually, understanding the precast system is very important, because even 1954 itself, in other countries, actually, there is a standard which prescribes utilization or use of precast or pre-stress system. Precast system always, okay, accompanied with the pre-stressing system. Pre-stressing and precast system go together. So you can find the application, building frames, parking structures, stadia, railway sleeper, transmission line, and many other segments. Now, actually, the precast system will be accepted everywhere, wherever you think about concrete, wherever you think about cast in situ. So only thing is, you have the precast elements, bonding them together is important, and connecting them together is important, integrating them. So we need to understand the methods to connect them. Connections are important because the weaker connections are possible. And we need to understand the binding material, cement grout, and the what do you call this, anchoring, okay, anchoring the precast element. It's very important whenever we talk about. Anyway, in the market, you'll find the solid elements. We can create the hollows to reduce the self weight. We can have the sandwich portion. Sandwich portion will be very lighter material. And you may have something wides like this so that high value can be improved, but you can span longer spans. So, and again, the selection of this one depends, okay, when you want to go for life of the structure is 10 years, 20 years, 30, or what is the cost involvement, how much advantage you will get, and the energy consumption, because we don't use much cement. We use only a kind of connection of the ready-made material, and thermal comfort is important. And whether you have the labor to connect them, skillfulness, or the materials required to join. And once you think about these things, what will be the maintenance of that structural system, and whether the components can be reused and recycled. So these are all the things now. It's not like yesteryear, but now we have to think about whatever you do, that has to be replaced, recycled. That is important. So these are some of the factors to be considered when you think about any precast system. Just okay, for understanding, is a kind of say column to be continued. A part of the column is constructed in the given reinforcement, and this part, another part is constructed like this. And these two can be connected by just okay, kind of nuts and bolts system, or a kind of anchors, okay, overlapping. This kind of thing. So this is a simple column to column. Now again, columns and beams can be constructed, and beams and slabs can be constructed. Like this is the skeleton reinforcement in the precast system. But once all these important components are being cast, okay, leaving the reinforcement required, you can bring them and you can join them together, and the gap can be filled with grouting material, and the connections can be okay joined by any stronger steel material. This is actually, when you look into this one, so advantage will have is speed of construction. Actually, previously the projects are delayed due to seasonal problems, environmental problems. Okay, rainy season, it's completely halt, and you can have only 3 or 4 months effectively. But now actually any season, these elements can be cast under a controlled environment. And we have the speed up very fast you can do. So you can have the foundation, you can have the casting of primary member, you can prepare all the members ready, and before the aggressive environment or whatever the seasons which are affecting the all practices, one can transport. And the design flexibility, any span, any dimensions, any shape can be possible. And you look into the fire resistant, because the longevity of these structural members are very high. You are looking for 100 years of its life. Whenever you look for this one, definitely fire resistance of the system is very high. They can sustain, they can experience the fire accident, but they can survive. And the durability, materials with long life we are thinking about. So durability of this precast system will be much, much better. And the maintenance cost or repair related things will be significantly reduced. Durability includes the life cycle cost also, reduce life cycle cost. And because these are stronger members, flexible members, pre-stressing is accompanied, and hence long span to depth ratios can be possible. A very slim constructions are possible. Pre-stressing enhances the performance and requires lesser material. Materials are being utilized very effectively. And when you look into a little far off place when you look, aesthetically feasible, pleasing, and acoustical control. So therefore, this is the advantage of this system. And thermal and energy efficiency. We don't use much energy for completing this process. Everything is being readily made, available, made it before. And hence, the less energy can transport and erect them. And the sustainability, the longer times. And so even in that, you can combine different materials, you can mix with the different material, use of efficient materials, energy resources, and minimizing the depletion of natural resources. That is actually main thing, sustainability. And improved quality, definitely after taking all these precautions, plant-made construction, definitely they are durable, more efficient, and the quality of construction is very high. Labor-related things, mixing, producing, can be overcome by this, good quality of precast system. And rooms, chambers can be constructed whatever the shapes you want, whatever the facilities you want to add. So future reuse for variety of function. So this is what actually the precast system, and hence it has to be looked into. Lot of investigations, lot of thinking. These are all some of the example. So the precast element here, this widened precast system, and all these number of precast elements can be joined to come out with aesthetically, architecturally pleasing system. This is something, runway is being constructed. Now, actually, the residential building or commercial building or stadia, and we have the beams, we have the slab, we have the columns, we have the step. All these things are readily made, required shape, required size. Only thing is, you know how to fix them. So we have to understand the fastening technology, connection technology, and the binding medium. This is something in mass construction, all these housing, or dwelling units can be fabricated, the 2 chambers or 3. Ready-made. Internally, everything can be provided. Now, actually, this is something in a mass construction, like you want to have similar spans. So there actually advantage, lot of money being saved to avoid the number of or the different sizes or shape. So the same size, same shape can be produced, and that can be used, and aesthetically it will be very pleasing. And here the gap can be cleared or supported by readily made deck slab here. And something like arch elements can be used, and these elements can be used to provide some kind of closure. These are the storage tanks actually. So one can use this one storage tank. All these elements can be fabricated. Provision for connecting. This is a connector. Connecting provision. So then they can be joined together. Then the whole the cylindrical tank can be constructed. This is very, very fast and mass construction. And of course, the sleepers already know. Now, actually, this is a typical bridge, for example, practical. The foundation was completed, pier was completed, pier cap was completed, and these pink colors, these are the bearings. On the bearing, actually, the superstructure comes. This is like 41 meter span, and this is the main part, the main waist, or this is the spine of the bridge in the longer direction, 40 meter, same cross section, but it may be curved, may be changed. It may not be straight. But actually, we have the left wing and right wing. Elevations may be different depending upon the curvature. So this is a typical cross section of a bridge, okay, flyover. This is the main part. This main part is being connected with the secondary part, this wing, left wing and right wing. And you have the precast element, segmental construction. All these segments will be connected by the pre-stressing in the transverse direction. And all these yellow elements called spine element segments, okay, provided in the length direction, each 15 meters or 20 meters, they are being again connected using longitudinal pre-stressing. You do this one, you maintain the levels, okay, and you bring them together, okay. Then once the pre-stressing is done, the gap will be cleared by the grout. Next day, this can be ready. Now, actually, this is one spine unit, and okay, when you look, okay, here, this is the skin, this is the stitch reinforcement. This is the end reinforcement. From the deck, it is coming. So this top reinforcement, okay, will be overlapped with the another reinforcement coming from the another segment. So these rebars will be overlapped, and that gap will be filled with your grouting material. Now, these are the provision, ducts are provided. So through the ducts, okay, the strands will be sent, or even other bigger pre-stressing element can be sent through. That is, okay, provisions are made, how many number of ducts you require, how many number of strands to be accommodated, and how to connect the top reinforcement. That is a stitching reinforcement. This is the main component. Like this, or 40 meters, okay, these elements will be joined longitudinally by longitudinal pre-stressing, and the wings will be connected by the transverse pre-stressing. And in addition to that, the flexural reinforcement here, the stitch reinforcement will be connected, and that will be completed. So now actually speed of construction, economy in the long span, and wherever the land cost is so high and it is required, okay, flyovers. And the prefabricated segments will be of good quality. Surely quality control is maintained in the factory or fabricated in the good environment, and hence overall quality is so good, and one can think about 100 years of its longevity. This is the casting yard, all your spine elements, all these wing elements, provision reinforcement, and you transport them, okay, and just okay, locate them and okay, connect them. There is a finally, this is the left wing, right wing, and the spine. The black color that indicates the grout to be completed. And we have the crash barriers and other things also. So parallelly, once the main structural system is completed, then one can think about it. In the okay, top okay, elevation, these are the different wings connected. The longitudinal pre-stressing, transverse pre-stressing, and this gap is filled with your grouting material. This is your longitudinal. This is a transverse direction. And this is okay, this symmetrically balanced way, okay, the construction is being done. So in the longitudinal, okay, spine will be constructed first, and the transverse okay, wings will be joined together. So it will be progressed further. Finally, this is the completed structure, and all other secondary units will be added. So whatever the gap remaining, that will be filled with your grouting. And now actually here you have to understand, this is the area where a lot of research can be done. This is the rebar embedded in the deck slab, and the rebar behavior is your reinforcement bar. And when there is a flexural compression or tension, we have the lugs or say deformation, then they experience a kind of inclined force. Resolve them horizontal component and the transverse component, radial component. The horizontal component will be, this is that. Horizontal component will be your bond stress, and the radial component will be trying to pressure rise the concrete cover. This is okay, surrounding concrete. This is your rebar, for example. You try to pull this. This is the radial pressure. The radial pressure is acting to split the concrete. So like a thin cylinder concept. It's very, very important. Unless you provide sufficient length of the anchorage reinforcement here, you cannot withstand the bond stresses developed. Otherwise, there is going to be a split cracking in the, okay, below the reinforcement bar up to the bottommost, okay, and in the horizontal direction between the rebar, and on the side, we have the side cover. This is possible. Otherwise, when a member is subjected to earthquake loading, in the earthquake loading, actually these top bars and bottom bars, they will be experiencing bond stresses. It's very important to understand the bond, but there are so many factors influencing. there is a factor like no size of the bar and the location of the bar, the surface characteristics of the bar, and the cover to the reinforcement and the transverse reinforcement, diameter of the bar, whatever, all the and yield strength of the steel and the strength of concrete. So many factors are influencing on the development length. But actually IS 456 provided only an ultimate case LD is a function of Fy and diameter of the rebar. Otherwise, these are all the factors influencing, and in the design equation, all these factors should be considered for the accurately obtaining the bond size. This is something the anchorage, okay, testing facility, test setup, and we have the original form IS 2770. But actually, the same thing is adopted now also to understand the bond developed corresponding to a given slip, replacement of the bar. That is displacement of the rebar with reference to concrete surface. Due to some reasons, this part is unbonded. Only this part is bonded. But the original form, the whole is embedded. But in the refined version, only the middle part is okay bonded. This is unbonded. This is unbonded. But actually, this information is required for us to okay use these okay bond parameters. This is the bond stress versus slip response, and this is the maximum bond stress P corresponding slip, and this will be horizontal plateau, that is tau 2, or this is nothing but again maximum bond stress corresponding slip, and the bond stress okay gradually decreasing up to tau 3 or tau f, and where the slip is S3. So we require S1, S2, S3, and tau 1, tau 2, tau 3, and K1 is the okay bond okay stiffness, and this is the secant modulus. All these things are required to model a reinforced concrete member in a strong software. So this is the bond actually very important. Now actually another important thing is actually special element beam. Is a shear wall. Shear walls are required in any multi-storied building. Wherever we have the ground motions, wherever we have the lateral forces, you need to have the okay laterally resisting elements, okay, shear walls along with the columns. These are all the actually slender walls okay tested with reinforcement under monotonic loading and cyclic loading. Actually, this is some kind of without reinforcement or with reinforcement and with the stiffening elements or boundary elements. Okay, typical shear walls were cast, and actually the comparison of the shear walls with boundary elements or without boundary elements, or with reinforcement and without reinforcement. Actually, these walls are constructed with okay, basic reinforcement, but additional rebars were added to improve the stiffness or to improve the other characteristics. But the comparison of the reinforcement provided and without reinforcement also. So what will be the drift of this one? That is the displacement at the top over the height. So these things, and this is a hysteresis response, cyclic behavior. We found actually reinforcement provided, okay, and it exhibited better capacity, better hysteresis, okay, behavior. And actually using that one, then theoretically, one can have a model. This is the experimentally observed load versus deflection curve. From this one, area under the load versus deflection curve is calculated. Now actually to define the ductility of shear wall, and an equivalent okay energy curve is okay developed by taking bilinear curve. So where actually this one linear part okay becoming horizontal. This is the deformation that is defined as elastic deformation, and horizontal plateau will continue up to this one du. Now actually area under this one, right? Bilinear curve equal to area under the actual curve experimentally. That gives the equivalence of the energy. So to determine the ductility, you can determine the ductility as the ultimate displacement to the displacement corresponding to the end of the linear part. Anyway, different, okay, the reports are given to calculate, and all these definitions are being, and from here the earthquake, okay, characterization. So the deviation, that is actually stiffness degradation. Stiffness decreases with increase in the displacement, because whenever we have the lateral force acting on the shear wall, cracking is possible. Depending upon the extensive cracking, then you may have the more degradation. So how the stiffness okay decreases with increase in the displacement or with increase in the okay cracking. So therefore again There's a comparison of the shear walls with and without reinforcement. And this is the actually final one, the beam column joint. It is a special element actually. It is being analyzed, or say importance is given in the real earthquake related experiences. These elements are vulnerable for shear. Even the red part, this is the confined region between the concrete from the beams on either side and top and bottom columns. There's a red portion that is called joint, which is common to beams on either direction and common to the column. That is called beam column joint. Actually, when the loads were only gravity, that was not given much importance because only it's a kind of support and no vibrations, no cracking, no inelastic deformation. But now the loads are different, but you just cannot support the beams, just you cannot have the columns themselves. But beams and columns, then everything to be integrated. The transfer of loads from the beams to the joint and from joint to the columns or columns to something vice versa. This way, they should be integrated. And this region, joint region is a common area which ensures the integrity and continuity of the transfer of forces. It's a part of the column, and as an element, it should be taken separately and then. And what is this? Yeah, so then actually the joints you find under gravity loading, not significant, not significantly deformed, no cracking at all. They are within the elastic limit, straight. But the type 2 joint is the one experiencing special loads, earthquake loads, or the wind forces, or blast loading effects. But they will have the nonlinear deformation, nonlinear straining, and cracking inside. So therefore, they have to be specially designed for this special load. It's a typical joint region subjected to loading. So we have the cracking like this in the column, cracking in the column, cracking in the beam. When you reverse the loading, then the tension becomes compression. Tension here, compression becomes tension, something like. So it's altering the sign movements. And hence now actually, you can see a plane frame subjected to earthquake loading, and you target the beam column joint. So the joint region will experience diagonal cracking. It is important for us whenever a tall building or any building which is not specially designed for these loads, and definitely they fail in the joint region because of this action. So because the building is moving in the lateral direction, and it gives you a kind of diagonal cracking, shear cracking. So hence it's important, all possible modes should be identified, and you have to design the system. Experience the possible loads and what are the weak points. The joint can fail, beam can fail, column can fail, but actually we need to see that no column, no joint should fail. Only beams can be made, weaker. That is what actually. So there is something, changing the sign and connection detailing, shifting the plastic hinges due to lateral force is possible. In the existing system, majority of the buildings were not designed for earthquake loads or special load, and we don't find any special detailing in the joint region. But whenever you experience earthquake like this, the joint region without special reinforcement will fail due to high shear force transmitted. And hence, these joint regions are very, very important. Whenever you have the multi-story building, if the existing buildings are not designed for earthquake loading and you want to protect them, then you should analyze the thing. So therefore, you have to understand the shear transfer mechanism. The shear force in the joint region needs to be calculated, and hence what is the shear capacity of the joint and what is the weakness and how to protect it. So this is what actually understanding the formation of the strut. So whenever the joint region experiencing loading, unloading, pulling, pushing kind of loading, the joint region experiences very high shear forces like the strut formation and inclined cracking. And whenever the cracking is taking place in the joint region, and the stiffness comes down and load carrying capacity comes down. So therefore, the reinforcement should be provided in a different form. So that is actually joint reinforcement. So to confine the concrete, reduce the joint stiffness degradation, slipping of the beam bars can be minimized, and the hysteresis response can be improved, energy absorption capacity can be improved. And hence actually the factors influencing the anchorage. So you should think about the joint region should be properly confined, and the diameter of the bar. proper anchorage length, and the good quality of concrete in the joint region. So all these things actually to be identified, and we have to analyze, and we have to look into this one, and then standardization. That is actually under extreme loads. So we have to be careful, and the special elements be preferred. This is what actually planned for today. And thank you for the patience, and thanks the organizers once again. Thank you so much.
Thank you, sir. Thank you very much, sir, Professor Apparao, sir, for your insightful session and for sharing your deep expertise on RC special elements. Explanation truly enhanced our understanding of advanced structural behavior under extreme loading. We are grateful for your valuable contribution. Shall we go for the questions, sir?
Yeah, sure.
Now we'll proceed for an interactive question answer session. Participants who wish to ask questions may kindly unmute themselves or post their queries in the chat box. I once again request the participants who have any questions kindly unmute themselves or post their queries in the chat box.
Good evening, sir.
Yeah, good evening.
Sir, can you please explain the where research can be done in this topic? In earlier slides, you said that there is a huge scope in this research.
Which slide? Related materials.
Yeah.
Yes,
I think 5th to 6th slide.
Yeah, just to see the slide I'm showing. This itself, lot of work can be done. Microscopic analysis.
Microscopic analysis.
Lot of work, micro cracking, and by changing different cementitious products, by changing the surface characteristics of the aggregate, or by adopting different admixtures or any special material, yes, these things will be different. So one can think about this one, right? So this is very, very important, in fact. And this is actually something many people, they are doing research using byproduct, but they don't understand the basic reaction actually. It's important. When they understand this, what exactly happening, and actually a lot of discussions can be made in the thesis. So to demonstrate to the other researchers. But they should understand it. They should understand clear about this and what byproduct they are adding, what will be the reaction with these basic reaction, and hence the final. So it's very, very important for the researchers who are doing actually. And this is another one actually. So not much work. It's very difficult to do it. And actually, so you take different surface characteristics of aggregate, and you can think about different cementitious material, and you try to improve the interface, because the interface is the only one actually trying to improve the overall capacity of concrete. Of course, when this is made very stronger, for example, this is cement matrix, and we have the interface. Cement matrix is stronger, interface is very stronger, and actually aggregate also very stronger. This will become a very brittle product. That's what actually. So when this is stronger, interface is stronger, then aggregate may be failing due to transgranular type. If the interface is not strong, and then you'll find intergranular. There's a kind of bond failing. It's a weak matrix. And like this, we can think about. So this is again cement grout itself. So commercially, there are different products available, and and all other characteristics required. Shrinkage related thing, then strength related thing, then bleeding related things, any other durability. So a lot of work can be done on durability, even cement grouts. And of course, this is what actually basic research we did, preliminary. Is a preliminary investigation, is a part of the, a kind of research come consultancy. So we adopted, somebody gave this material and we convert this one like a research program. And you take the structural components also under different loading components, individual elements you take out, and you can model it in the laboratory or in your computer. You can work out shear walls or by changing different characteristics. One can do it.
Yes, sir. Thank you.
Yeah.
Hello. Good
Yeah.
evening, sir.
Yeah. Good evening.
Yes, so one more question I have related to interfacial transition zone. How we can measure the ITZ except the SCM?
Except?
Scanning electron microscope, sir.
Yeah, that is true. That is true. Yes, yes. Even you can go to the magnet. I mean, you can magnify, even other level also.
Okay.
The
So
micro,
other
normally
than
micro level, but now actually it's advanced. Okay, you can go to nano level also. That's what actually. So understanding that one, what best way you can fill that gap also. So you can improve the characteristic. The whole idea here is, it is like a completely solid, say 100% solid, and it is an ideal solid, no voids. That's what your mathematics and all your equations connected, stress versus strain response, and finally something calculated. But in reality, all realistic materials will have a kind of voids. It's not completely solid. So even micro level, if you try to fill, micro filling, and in the nano level, nanoparticles are also being produced now, nano filling. If it is possible, by producing nanoparticles also, incorporating in your cementitious product, and one can fill the nano voids also. That's what finally you are going to come out with, more like a solid. And you know what is the solid, strength of an ideal solid? It is E by pi, 3.142. That is modulus of velocity divided by 3.142. It's a huge ideal strength. But with real materials, they have only limited strength because of weaknesses during the manufacturing, during the production. So that is what. So you can think about how best the micro level, nano level things can be rectified to have your ideal solid.
Okay, sir. Thank you so much, sir.
Right? There are so many participants, about 220. So it's a big number. 220 participants. It's a good. Actually, these things come
Questions
to my
from any
mind.
other participants?
Yeah, please. Any questions? Okay, yeah, I think if we don't have any questions, I think the
Yes, sir.
organizer.
Shall we conclude, sir?
Yeah, sure, you can.
Thank you very much, sir. On behalf of the organizing committee and all the participants, I sincerely express our gratitude to Sir Apkara, sir, for sparing his valuable time and sharing his rich expertise with us today. We also thank all the participants for their active engagement throughout the session. With this, we conclude the first session of our ALCTE ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. Rejoining shortly for the next session in a couple of minutes. So we'll be waiting for the resource person to join. Please be back. Stay back. I request all the participants to stay back. I request all the participants to disable their video, and we'll have a screenshot of the first session.
Madam, start video is not enabled.
Okay, sir, I'll check. Sir.
Start your video now, sir.
I request all the participants to disable the video such that we can take a screenshot of the first session.
Ma'am, it is showing that the video is disabled by the host.
Sir, I have okay, sir. So you can on the video, sir.
Now it has enabled.
Yes, okay, sir.
Ma'am, actually, I cannot turn on the video.
Okay, ma'am. No problem.
Ma'am, video disabled by the host.
I have enabled, ma'am.
Yes, I am having the same. The video is disabled by the host.
I have enabled, ma'am. Just once again, you check in, ma'am.
Even for me, the same.
Cannot start your video because the host has disabled, ma'am.
Yes, sir. K. Prabhakaran, sir. Sir, unmute and you can chat, sir. Hello.
It is also showing the host has disabled group chats.
Sir, I have enabled, sir. I'll check with the problems.
Ma'am, the chat is also disabled.
Chat is enabled, ma'am.
It is showing that the chat is disabled.
Still it is showing the host has disabled. Now it is showing.
Sir, I have enabled. Yes, sir. Thank you, sir. Thank you to all the participants. So we'll be joining shortly. I request all the participants to stay back. We'll be resuming the session in a couple of minutes. Good evening, sir. Am I audible, sir?
You're audible, Arunima.
Joshua, sir. Am I? Hello?
I can hear you, madam. Can you hear me?
Okay, yeah, yes, sir. 1 minute, sir. Welcome to the session 2 of the day 1 of ALCTE ATAL Faculty Development Program on Sustainable Practice and Innovative Trends in Civil Engineering. We are delighted to have you here with us, sir. Mr. Joshua Richards, Senior Principal Civil Engineering at System UK, share your valuable insights on the topic application of programming and automation in civil engineering. Before we begin, I now invite our faculty colleague, Dr. M. Amreshwari Reddy, Associate Professor, to formally introduce our eminent speaker to the audience.
Thank you, madam.
Over to you, ma'am.
Thank you, ma'am. Madam, my voice is audible to you?
Yes, ma'am.
Thank you. It gives me a great pleasure to introduce Mr. Joshua Richard, a distinguished professional in the field of civil and structural engineer. He currently serves as the head of the department, Civil Structure and Architecture at SSTEM, Energy Infrastructure Limited, United Kingdom. Mr. Joshua is a distinguished and accomplished civil structure engineer with over 16 years of professional experience in design, engineering, and technical support for nuclear power, nuclear fuel cycle, industrial, and commercial sector. Throughout his career, he has contributed to several national and international papers and complex engineering projects, ensuring structural safety, quality, and innovation at every stage. He holds the MTech in Civil Engineering Structure from NIT, Calcutta, and BTech from National Institution of Jawaharlal Nehru, Kakinada. Mr. Joshua is chartered engineer and a member of Institution of Engineer. He is passionate about industrial automation and innovation and believes in encouraging creativity idea among the young engineers while maintaining a strong professional ethics. Sir is also have a wide range of advanced engineering tools such as Stratco, ANSYS, ProE, and Excel VBA, which he used to integrate automation and computational efficiency in structural engineering. With his deep technical knowledge, global exposure, and commitment to innovation, Mr. Joshua Richard constitutionally to inspire the engineers and research alike. We have honored to have him with us today to share his valuable insight and experience that bridges the gap between the academic learning, industrial practice, and innovation engineering solution. Thank you, sir. Thank you for your glorious sparing your valuable time with us. Over to you, ma'am.
Thank you, ma'am. Now, without any further delay, we hand over the session to our esteemed resource person, Mr. Joshua Richards, to share his expertise on application of programming and automation in civil engineering. Sir, the session is now over to you.
Okay. Thank you all, and especially thanks Arunima and Amareshwari Reddy for the kind introduction. I'll just share my screen and let me know if you're all able to see my screen.
Yes, sir. It's visible, sir.
Okay. So, good evening, everyone. Without no further introduction, I would like to dive into this topic that's fundamentally changing our field, the impact of programming and automation. As the title suggests, we'll have a major focus on one of my fundamental disciplines, which is the structural engineering, as it's a prime example of this computational shift. But to give you the full picture, we'll also take a holistic survey of how these tools are being used across all of civil engineering. The goal isn't just to show you what's happening, but why it's helping us create stronger, smarter, and more efficient design. And therefore, I'm excited to share these insights with you. So this is the presentation outline, which I have put in. Like one would be mostly focusing on the structural engineering, then section 2 would be on the other disciplines, and then therefore we'll be concluding with the engineers programming toolkit session. So the introduction. Okay, so let's start with a quick refresher. We all know engineering is the foundation, and especially civil engineering is the foundation of society. It's not just one thing, it's a collection of vital disciplines which you see listed here: structural, geotech, transportation, and so on. Traditionally, these fields have been quite distinct with their own tools and methods. Our focus today, as I mentioned, will be a deep dive into the structural side. But what we'll see is that programming is becoming a common language that's starting to connect all these disciplines in new ways. When I say programming, just don't think that I'm not necessarily talking about becoming a Silicon Valley software developer. I'm talking about writing instructions from a simple script in Excel to a complex Python program to control our analysis software. Automation is simply the result of that programming. It's getting that computer to do the repetitive work for us. The key thesis for today is that we are moving away from just being users of software, clicking buttons, and towards programming of entire workflows. So why bother? The first reason is complexity. Our buildings are more complex and our analysis codes are far more demanding than ever before. Second, efficiency. Think about all the time you spend on repetitive tasks. Automation gives you that time back to actually be an engineer. Third, accuracy. Every time you manually copy a number from one program to another, you risk human error. A script does it perfectly every time. But the most powerful reason is optimization. A script can run thousand what if scenarios overnight, finding the best design, not just the one that works. And finally, safety, which should be a bit of caution for everyone as civil engineers, that both in design accuracy and also by using the latest, as you can know, the robots and drones have also been used to track the dangerous tasks on site. All right, let's deep dive. For the next 20 minutes or so, we will be focusing entirely on structural engineering. I call this programming the skeleton because that's what we do. We design the core structure that holds everything up. We will look at three key areas: how we analyze structures, how we design and model them, and how we manage their entire life cycle. This isn't just about doing things faster, it's about doing things that were impossible to do manually. So, as we all know, which is a major development in the recent trends, the workhorse for almost every modern structural engineer is the finite element analysis, or FEA. As you know, this is the numerical model we use to simulate a complex reality, breaking a bridge or building into millions of tiny elements. We use it to find stress, strain, and displacement under various loading conditions. Historically, we have been users of FEA software. We build a model, click run, and look at the pretty pictures. The shift we are talking about is programming the workflow around the FEA, which we'll see in the next few slides. The automation workflow starts before you even run the analysis. This we all know is called pre-processing. The problem is that manually building 10 variations of a model to test different base spacings, for example, is incredibly slow. The solution is to write a script. We can use Python or even C# or even Excel VBA to automatically generate the model geometry and assign properties. A great example is a script where you just input height, base spacing, and column size, and it builds the entire 50 model story for you. This is the core of what we call the parametric analysis. Next comes the solving phase. Running one analysis is easy, but what if you need to run 1,000? With a batch analysis script, you can. You can tell the computer to run 100 analysis overnight, testing 100 different beam sizes and have the results on your desk in the morning. But we can go even further with probabilistic analysis or Monte Carlo simulations. This is where we run thousands of simulations, each with a slightly different material strength or load based on statistical distributions. This lets us move away from a simple factor of safety and towards a much more realistic probability of failure, which is a major leap in the design. Next comes, sorry. Next comes the analysis automation. So this might, uh, apologies, I'm hearing some background noise. Yeah, this might be the most important part. The analysis is done and the software gives you 20 gigabytes of data, for example. Then the real question is, where's the answer? The problem is that engineers spend hours or even days digging through results to find out the one or two numbers that matter. The solution is to write a post-processing script. This code automatically scans all the results for you. It can be programmed to do things like extract the maximum moment in every beam or flag any column where stress exceeds 80% capacity. Ultimately, it can generate a one-page PDF report, turning a week of work into 5 minutes run. Building codes, for example, we have ASC 7, or even let's take the example of IS 456. As we know that these codes required us to check hundreds of different combinations of dead load, live load, wind, seismic, and so on. The old way or the traditional way was to manually type this into software's GUI. It's tedious, boring, and prime spot for human error. The new way is to write a simple script, often in Python or VBA, that connects to the software's API. API is the application programming interface. This script reads the load cases from a simple Excel file and automatically generates all 200 plus required combinations in seconds. Automation really shines when we get to advanced nonlinear analysis, especially for seismic design. A push-over analysis where we simulate pushing a building until it fails is computationally expensive. A time history analysis where we apply a real earthquake record is even more so. Using scripts, often with tools like OpenSeas, we can automate a full performance-based design workflow. The script can run the analysis for 10 different earthquake records, extract the peak interstory drift for each, and automatically plot them against the code's acceptance criteria. This is one of the classic example of the recent trends wherein which we have a shift of moving from analysis to design. The biggest trend is the parametric design. So what is meant by parametric design? This means that we are designing the relationships and parameters, not with static fixed geometry. The classic example is a truss. We program it so that the truss depth is equal to 0.1 times truss span. Now, if the architect changes the span, the whole truss automatically updates. We don't have to remodel it. The key tools for this in the latest current software tools are Grasshopper and Dynamo, which are very popular for complex architectural forms. Next comes the generative design on topology optimization. Here we don't even tell the computer the form. What we do is, as you can see on the screen, we tell it the goals. We say, I need to connect point A to point B and the load is X and your goal is to minimize the weight. So a specific type of this is topology optimization, which you see in this image. It carves away all of the unneeded material and it's just the last picture which you see is the one which is the most efficient material which has been optimized for weight, leaving only the most efficient organic looking load paths. This is moving from aerospace and even now into structural connections. Let's be honest, the number one bottleneck, which you all would be noticing already in the design office, is not analysis, it's code checking. It's the mind numbing task of checking every single beam, column, and connection against the design code, like ASC 360, for example, or let's say the Indian Standard Code for structural steel. This is a perfect task for automation. We can write a script that takes all the analysis forces like moment and shear, pulls the member properties, calculates the capacity, and compares the two. The result is a pass or fail report with utilization ratios. The engineer's job is to now review this summary, not to create it. Next comes the design automation. So this concept is incredibly powerful for steel connection design. As you can see on the screen, a large building might have 10,000 individual connections. But if you see specifically, there might be only 50 or 60 types of connections, which are repeated over and over. A script can be written to scan the entire model and group all the connections that have identical geometry. It then finds the worst case for each group. You, as an engineer, or we as engineers, just design one connection for those worst case forces, and the script applies the design to all other connections in the group. Next comes the BIM 3D model, which is most widely used in all of the sites nowadays. The most important thing to understand about BIM is that it's not just a 3D model. A program like Revit is at its core a programmable database. Every single object in that model, every beam, column, and bolt has geometry, but it also has the data. So this data, like material, size, status, or cost, is fully accessible. And because it's a database, we always have the opportunity to write code to read from it, and more importantly, write back to it. For many engineers, the gateway to programming is BIM, is through visual programming, like for example, Dynamo or Revit. You don't even have to write lines of text-based code. Instead, uh, apologies, I'm hearing background noise. Could you please mute? It would be grateful for me.
Yes, sir.
Yeah. You don't have to write lines of text-based code. Instead, you connect functional nodes or bricks. As you see in the image, a simple script might be get all columns which flow to read their location, which flows to place a footing. This is the power of programming, and it's right now being in place, and we do it day in and day out. This script can now place 500 footings perfectly centered on every column in about 3 seconds. This is the power of the visual BIM modeling, which allows and creates visual approach, lowers the barrier to entry, and gets designers thinking like programmers. Now comes the end product, which is on the automated drawing and detailing. The holy grail for many firms is automating their drawing production. The problem is that creating hundreds of 2D drawings sheets from the 3D model is still a very manual and tedious process. With programming, we can write scripts to automate many of these tasks. For example, we can automate the rebar placement in complex concrete shapes based on design rules, or we also have an option to write scripts to automatically place the tags for each rebar and the shape code and section cuts, and then update them all with one click with the model changes. Another huge win, which of course we are doing it here in day in and day out, is automating the bill of quantities or even the takeoffs. The old way, as I have done in the past, or many of us have done in the past, was in which involved a cost estimator with a set of 2D drawings, and he would have a highlighter which he would be manually measuring and counting. It's slow, and always, as we know, we need to have a checker as well because it's slow and prone to error. The new programmed way is a script that runs on the live 3D BIM model. The script can instantly and perfectly calculate the total tonnage of steel broken down by shape, or the total volume of concrete broken down by strength class. This means you can get an accurate cost estimate in minutes, not weeks, and you can rerun it every time the design changes. Now, the next or the last part of this session is the structural health monitoring, which is one of the important tasks as well. This is majorly a shift about the life cycle of a structure. SHM is, I can say that it's similar to a nervous system for a bridge or a building. It's a network of sensors like accelerometers, strain gauges, and fiber optics that are permanently installed on the structures. These sensors generate a massive continuous stream of data 24/7 for the entire life of the asset. This is a classic big data problem, and it's a perfect fit for programming. Here comes the lifecycle programming for SHM, wherein we see that most of the data is 99.9% noise. So the first job for a program is to filter and clean out. Next, we use anomaly detection, wherein which the building's normal vibration pattern, for example, we can automate it and flag any strange behavior that doesn't fit the pattern. For example, it can also prompt the alerts for automated email notifications, wherein which it's triggered some anomaly and sends, for example, sensor 12 on bridge where 4 has detected anomalies. So this is the overall flow till now whatever I've spoken. To summarize our structural deep dive, I hope you can see how programming connects the entire process. It starts with parametric modeling in a tool like Grasshopper that feeds into an automated analysis workflow, maybe using Python. The results are automatically checked using scripts, perhaps in VB or Excel. That drives the MIM model automation in Dynamo. And after construction, the data algorithms manage the building's entire life cycle. So before I move on to the next section, I would like to show you some examples which I have done in the past, and it would be more interesting when we focus on Excel because we use Excel as a day in and database every day in office. Okay, so if you see here, I'm just trying to show an example for a machine foundation analysis. So when we do a machine foundation analysis, we also need to require the parameters of mass, the damping ratio, the amplitudes, the velocity displacement. Yeah. So here I've just taken this database. Let's say I've given the initial displacement as 0.05. Yeah. And what I try to do is I try to predict the response. So as you can see, all of this program I have written in Excel, and it is able to give me the overall response when it comes with respect to transient and steady state. Okay. So, and this is the overall response where you can see. Now, in addition to that, I just want to show the capability of Excel, what all it can do. So you can see here, if I want to know the free vibration of this foundation system, which I have idealized as a single degree of freedom system. So you can see here, I'll just try to show the animation. Okay. So as you can see, Excel, what we see as a normal database has much more programming capabilities where you can simulate not even the static response, but also on the dynamic response. This is one of the example which I have spoken just now to what all Excel VBA can do. So the script is in Excel VBA. The second example which I want to show is our column design. So what actually we do is, for example, if we are working in StatPro or we are working in SAP or ETABS, we always try to get this member forces. And you can see for one member, how many load combinations we have. Okay. So instead of doing the design in StatPro itself, because StatPro has its own constraints with respect to its own design, what we do is we try to put the practical rebar diameter from the site, and we can create so many groups of such cases, and we can assign that group number, let's say here. Okay. And then afterwards, what we do is we try to run the column design. So you can see here, what eventually happens is the output is that it gives the governing load combination, and also it gives us the utilization ratio or the interaction ratio. That is how much margin we have. Okay. And in addition, what we can also see is these are your interaction curves with respect to the major axis and with respect to minor axis. And this dot is nothing but your P and M coming from analysis. From here, we can able to predict how much margin we have. So this way of doing the work not only makes the engineer more robust with the database, but also make the engineer think as to what actually the reinforcement coming from the site is aligned, or even the practical diameters are aligned with respect to what needs to go into your design parameters, which eventually can be backfaded into your Tekla model or any 3D modeling reinforcement software. And I want to show you one more example. Okay, so as you would be knowing, we would have so many load cases and so many load combinations. Someone can say that we can also take the software's inbuilt load combinations, but here what happens is in the industry, because of the client requirements, it's not that all of the load cases can be captured within a set of codes and standards. Okay, as codes and standards are the guidelines. So what happens is we need to create our own load cases. Let's say, for example, here I have just given you the load cases here. Okay, and for each of these load cases, I have given the load type. And for each of these load types, we have given the load combination factors. Okay, so now what happens is any engineer who's working on a project can feed in the data of what all the load case factors are coming from the design code. And from there on, what you can do is, in addition, you can see here, I have developed this add-in, which means the add-in gives you all of the parameters wherein which even, for example, if I show you here, I can even generate the entire model. I can generate the entire model from Excel, because in Excel to STAD, we have something called as Open STAD API. So with this grids database, we can also generate the entire model by means of parameters. So if the grid spacing changes here, we can change the spacing, and automatically the software can pick up this data and generate the model for you. Okay, so let's go back to the load combinations and try to see or try to generate the load combinations. So if you see, it has generated the load combinations, and this is what actually comes out from the Excel program. So you can see here, it has generated the set of load combinations as per the syntax of a given software. Here I have taken the syntax of STAD. So it has given the syntax of the STAD software. You can copy paste this entire set of load combination text file into the STAD file and generate all of the designs in one go. That's the beauty of having this parametric kind of design connected with any software like STAD Pro, SAP, or even ANSYS. But the interface here is Excel, as I have shown here. So such is the capability of any programming software, and such is the capability of generating any kind of 3D modeling with this parametric based of design. So this is on the focus mainly, which is emphasized on Excel. Now I'll take you for one more example, which I'm showing you on the screen, the Python script. Okay, so as you can see, I have used the finite element code OpenSys, which I have spoken in the past, and I'm trying to analyze different kinds of truss configurations. Let's say, for example, here, if you go here, you have, let's say, Pratt type truss, or even Warren truss, or even Hovet truss. So right now I'm using the Pratt truss. You can see here, this is a variable. Okay, span length is a variable, height is a variable, divisions is variable. So whatever you change here automatically will come out in the design, and you can also see what's the stress pattern. So if I run this code, so this is what actually comes as an output of this code. You can see the number of spans which I have given as an input, the height and the width. And based on this, you can always see the corresponding stresses and the force magnitudes. So if you want to change, it's just matter of seconds that you can just change the number of spans here and again rerun the entire code. Okay, so such is the capability of the so-called parametric design and its usage. And as myself, if you see from the past years of my experience, I have been very well using this kind of parametric designs, which would save a lot of time as an engineer, and it gives more time for us to make more efficient design, and also which is giving an output which is productive and with quality to the client as well. So now let's go back. Let's go back to the presentation. Okay, so since we have completed the structural part, now I would like to take you to the survey of other disciplines. So now I want to take a step back and see what's going on in other disciplines. My goal here is to give a holistic view. And to be honest, I'm a structural engineer, but I tried to gather as much as information what is going on in other disciplines to see what's coming and what way they have parameterized. And also I would like to share, there are many upcoming softwares which it's impossible to put me on the screen, but I have whatever I have known and whatever I've seen, those are the ones I have kept it for your benefit and information. So first thing is the geotechnical problem. So as you know that, let's start. The classic problem for a geotech is that you only have a data at a few borehole locations, but you need to know what's happening between them. Programming, like for example, the software which I've shown earlier, Python, it allows us to take hundreds of these digital borehole logs and use geotechnical algorithms like rigging to interpolate the data. The result is a powerfully programmable 3D model of the surface, which is a massive leap forward from 2D cross sections. The next problem, as you all know, is the checking of the slope stability. But as we all know, the result is highly dependent on water level and soil strength, which are uncertain. So instead of a single factor of safety, what we can do is we can write a Monte Carlo simulation, which can run the analysis 1,000 times. And the result is much more powerful probability of failure analysis, which is the same concept we saw in the structural section. And just like in structural automation is used for both design and monitoring, many geotechnical calculations like pile capacity are done in-house using automated Excel VBA spreadsheets, the ones which I have shown like before, that checks dozens of load combinations. In the field, digital sensors like inclinometers or piezometers are installed in excavations or tunnels. A script on a server then pulls this data automatically and plots tunnel movements versus time, alerting the engineer of any dangerous trend. Now comes the topic on the transportation, which I have focused majorly on the traffic simulation and modeling. So in a software like Vissim or Sumo, you are literally programming the behavior, not like the structural part, but indeed we are trying to monitor the behavior of individual agents, like for example, the cars, the pedestrians, and the cyclists. You can code their design speed, their reaction time, their driving aggressiveness, and so on. This lets us run powerful what if scenarios on our infrastructure. We can script and test questions like, what happens to congestion if we close this lane? How does a new light rail line impact traffic flow? So these are the prompts, or these are the questions which in fact can be taken up as the basic inputs and coded for these kind of parametric design softwares. And of late, we have seen that in transportation, automation is not just in simulation, it's in the real world, because transportation is not like the same kind of examples which you have seen on a structural point of view, because all are connected in the real world for transportation, and we call it as intelligent transportation systems. The most obvious example is, for example, an adaptive traffic signal. So let's say this is not a dumb timer. It's a system that uses cameras and computer vision, which is coded to detect real-time traffic flow. An algorithm then adjusts the signal's timing on the fly to clear congestion. Other examples are automated ramp meters on highways so that it gives a prompt. And even as you know, if you can see in your day-to-day four-wheelers as well, you have monitors which have been fit in your system, which tells you that if it tries to find a sensor wherein which the speed limit is 40 kilometers per hour, it sends you a signal back into your monitor in the car itself, so as to slow down your speed. Or if you are well below the speed, it tells you to go at a higher speed. Other examples are also linked to variable message signs that are programmed to automate and update. Then comes also on the topic of the pavement design. In highway design, just like in structural, we use parametric tools. In civil 3D or open roads, or be it any software, you can change one curve in the alignment, and all the earthwork volumes, sight lines, and super elevations automatically recalculate. For maintenance, cities use optimization algorithms. They feed in their entire road network data, their limited budget, and the program finds the most effective 5-year maintenance plan to get the most value of their money. Now, on the hydrological side, moving on to the water resources, their workhorse is the HECRAS modeling software. Of course, there are many softwares which are in place. Just like our tools, this also has a Python API, which is a total game changer. This means an engineer no longer has to manually run 10,000 different scenarios. They can write a script to run the 100-year storm event, which eventually will give you what is the corresponding groundwater level to be considered from the design. And also, for example, when we do the structural design, or be it for the bridge design, it can simulate for you what is the probable groundwater table based on the climatic conditions as for a written period of 100 years. And this script can be automatically run all 10 times if you want to do 10 simulations, and extract the result in terms of flood elevations and plot them on a graph. We can connect these models to create automated flood forecasting systems. This is a workflow of several topics working together. First, a script runs every hour to automatically download the latest radar rainfall data. It feeds this data as an input into a pre-built HEC HMS hydrological model, which calculates the predicted river flow. A final script checks this flow, and it exceeds a trigger level, it automatically sends an alert to emergency managers. There is another platform which is called SCADA, which is programmed basically on the brain of the plant. It's the code that controls all the physical components. For example, this code is responsible for automatically opening and closing valves, changing pump speeds, and managing chemical dosing. On the network side, they use genetic algorithms, a type of code to optimize the system. These algorithms test thousands of pumps schedules to find the one that means and maintains the water pressure while using the latest amount of energy. The next part is, as we all know, as we have seen in the latest construction trends, the automation is linking also the digital model to the real world time model. So 3D is nothing but the 3D model in XYZ. And the fourth step is we are adding the time. And the fifth step we are adding is the cost. So the result is a digital rehearsal, a video simulation of how the building will be built, letting them find clashes in time, not just space. Then you have the 5D BIM, which is programming the link to the cost database. This is incredibly powerful. It means you can change a beam size in 3D model, which in turn connects the analysis model, and in turn gives you the real-time impact on the total project cost. And these updates eventually are all automated. Of late, we have seen that the biggest change now on the construction side is from drones and computer vision. The automation part is simply RAN, which is an autonomous drones files a pre-programmed path over the site every single morning. The programming part is what happens next. The drone creates a 3D scan, which eventually would create a computer vision algorithm, compares it to yesterday's scan. It can automatically calculate progress like 300 cubic meters of earth were moved in area B. That's what actually we are right now seeing of late in the construction industry as well. And even more than that, more advanced AI can also scan photos and automatically flag safety violations like person detected in this zone at this place and so on. Now, with respect to the robotics and 3D printing, and finally, which we have eventually come across this at various places, be it on the other fields as well, that we have robots that can tie rebar, robotic welders, and even bricklaying robots. The most extreme example is 3D printing, where a giant robot follows a certain path and extrudes concrete layer by layer to print the walls of a house, turning a digital file into a building. On the geographical information system, it's eventually a database for location. And just like BIM, this database is also programmable. Using a Python library, an engineer can automate complex spatial queries. Instead of clicking 100 button, they can write one script to ask a complex question. For example, show me all potential landfill sites that are more than 1 mile from a river, and eventually it gives you the database or the required data based on the script which you have programmed. Coming to the environmental side, like other disciplines, environmental engineers use also programs which are mainly emphasized on models to simulate reality. These models predict the fate and transport of pollutants in the environment. For example, a program like AR mode is programmed with fluid dynamics to model how a smokestack's emission will disperse in the air. A program like ModFlow does the same thing, but it models how a chemical spill will travel through the groundwater. Now comes the automated monitoring, as just like in structural, monitoring is a huge application. We are seeing the rise of Internet of Things, networks of low cost, connected sensors. As you can see on the screen, there are various steps which we need to do. This can be placed all over a city to automatically measure air quality, or in a river to measure water quality like pH or turbidity. A script on a river automatically collects this data 24/7. Then the program checks if any values are exceeding legal limits and can generate the daily compliance of reports for regular agencies. Now comes to the end part of this session, which is on the engineer's programming toolkit, which eventually any current engineer in the civil engineering side right now in the latest trends is following. So as you might be knowing, there are various code languages which there is a shift not only on the software side but on the civil side. So a civil engineer, apart from knowing the core basics of the fundamentals, be it on the structural engineering side or be it with respect to various disciplines, the idea is to have at least a basic understanding of the various softwares right now in the current trends. And even the clients or even the industries are looking for those candidates who are proficient not only or not only having grip on the subject, but also who are having these capabilities as well. For example, Python, the top language, which is easy to learn and which has various science libraries like NumPy, Pandas, Excel, and of course the day in and day out use software, which is VBA Excel, which I have just shown as an example, is the most used even in the current industry practice. And apart from that, we also know we could use MATLAB, C# as well to connect softwares like StatPro, Revit, and SAP. It's easy to learn. It has powerful data science libraries, but at the same time, what I would say is that what I showed with respect to the example on Excel, please don't discount, because it's the most used and most relevant part, which I always still believe is the powerful tool in the industry. Now, the entire toolkit with respect to the glue of all this automation is the API, application program interface. So for example, as I told before, STAD has its own application programming interface. Similarly, we have SAP, which has its own application interface. So what we can do ultimately is learn one of the most powerful softwares, not to the extent like a proper software or a coder, but just the basic logics what we need to program. And let's say, for example, I learned Excel with VBA, and afterwards what I do is I connect that to the application programming interface, and there afterwards what we do is we entirely model the full building in terms of parameters. And whenever we change the spacing grids between the base, automatically when they run the Excel VBA code, it will ask or it will open the STAT software so that it will go with the right spacings, right floor spacings, and then afterwards with the load combinations which I have shown earlier, it can it can be copy pasted in the STAT editor, and we can run all of the design code also by means of Excel which I have shown earlier. So this is the overall sense or the overall seamless workflow automation which will make the engineer's life simple and also at the same time make it more visual. Once you start writing code, you need to manage it. So you can't just have script final like with different file names. What you can do is now with the latest trends, you can also share the code in a shared drive. Then afterwards, for example, the Git and the GitHub is the most popular platform to do this sharing. So you can think of it as track changes for a code. So it's essential for managing scripts. So anything has if anyone is working on a software code, let's say 10 people are working and you're able to share this code on a given database. So people can throw the queries on this through a sequential query language, and it's most efficient also to take into or spot errors in the code to recorrect it, and eventually this cloud-based platform program can be invoked and downloaded into the local PC again to rerun the entire model. The future and the conclusion. So let's wrap up by looking at the future. We have seen what's possible today. Now, where is this all heading? The next frontier is about moving from simple automation, doing what we tell it, to intelligence, making its own decisions. The future, as I think I don't need to tell what's the future right now and what's looking, because AI also has taken a big leap into everywhere. And a great example is predictive maintenance. And then it can predict a failure before it happens, which is a huge leap beyond just detecting an anomaly. This AI model can then predict the result of how new analysis instantly without having to run the full hour-long FE analysis simulation can very well be managed within few seconds by using the machine language models, which are inbuilt in the AI. The second major trend is the computer vision, which is AI that can see and understand images. This is being used to train AI models and automatically identify, classify, and measure every single track. It's also being used to scan video feeds from a construction site and automatically identify unsafe practices. A really exciting one is using AI to read old scanned 2D blueprints and automatically convert them into 3D BIM models. The final goal, which in fact we in the organization are also working, is the digital twin. So what is digital twin? It simply means it's not just a 3D model. A digital twin is a live synchronized digital copy of a real world asset. It combines everything we have talked about: 3D BIM model, the finite element analysis physics model, and the real time sensor data from this system. This allows an operator to see the real time stress on a digital version of the bridge. And even better, they can test what if scenarios. What if an overweight truck crosses now? Or what if a 5 magnitude earthquake hits? They can run the simulation on the twin before it happens in the real world. As I said, it's the start, and I'm not saying that we are all accustomed with these skills, but I only can request and convey to you is that it all sounds great, but it's not a perfectly easy transition. There are real challenges. The biggest one is the skills gap. We need engineers who can code and coders who understand the engineering physics. That's a rare combination. There's also a simple human inertia. We have heard that we have always done it this way in every office. We need to be flexible as to welcome these type of challenges, and also these kind of rookie ideas to come into our civil engineering industry practices. And interoperability is a huge technical hurdle. Getting Revit or SAP and Excel to all talk to each other is still very difficult. And finally, a new legal and ethical question: if an AI generated design fails, who is liable? That's the question which I leave it to you. It's ultimately at the end, the engineer. Whatever I say with respect to AI, eventually we are all engineers again to check and ensure that those numbers make sense, which eventually make us to deliver a safe design. This all leads to a new model, which I call it as a tree-shaped professional. So the vertical bar of the T is your deep specialized knowledge. For me, that's structural engineering, or be it any kind of specialization which you are in. The horizontal bar is a broad knowledge of other domains and critically a knowledge of programming, data analysis and automation. Your value in the future won't come from your ability to do a repetitive task like checking 100 load combinations. Your value or our value will come from our ability to write the script that automates the task, freeing up to solve the real engineering problems. So with this, I wrap it up all. I have shown you that programming isn't some separate IT skill. It is fundamentally the new way we are going to design, build, and maintain our world. It's the tool that lets us manage complexity, optimize our designs, and build more resilient infrastructure. It's the common thread that connects every single discipline of civil engineering. Thank you for your time. And if there are any questions, I'm happy to answer, if any.
Thank you, sir. Uh, Thank you, sir, for an inspiring talk on automation and programming in civil engineering. Your practical insights into global engineering practices and digital innovations were truly enlightening. Your talk has truly broadened our understanding of the diverse branches within the field and how they interconnect to shape the innovation and progress. Truly, sir, your session has covered all the major areas of civil engineering. So I request the participants who wish to ask any questions can kindly unmute themselves or post their queries in the chat box. Any questions from the participants can kindly unmute and post their questions in the chat box. Sir, one question.
I think there was 2 questions I'm seeing.
Yes, sir.
About the skill gap.
Yes, sir. Sir, where can we learn the VMA for structural engineering? Any course suggestions?
Yeah, so I think the question is on the Visual Basic application, right?
Yes, sir.
Yeah. What actually I have done is initially when I have started the career as a structural engineer, I used to follow cpearson.com. That was the website which I heavily followed for Excel VBA. And there is another help available in each software itself. Like for example, STAD, if you go into STAD help, they give a full database on what is STAD OpenAI. You can always look into that help modules. And one of the websites which I mentioned, cpearson.com, these are, I would say, to start with, you can explore these websites. And even SAP has its own help file, which gives you Open API. You can just type Open API or Open STAD in STAD software, which will give you full details on this.
Yes, sir. One more question from V. Prabhakar. Session was truly amazing. Thank you, sir, and the whole team. As you mentioned about the skill gap, where should we start and what reliable sources can we refer to learn more?
Yeah, that's a very good question. I agree, because what happens usually in the industry, the expectations now have gone beyond, and we expect that every engineer who comes out from the college is equally experienced enough in programming. So in terms of skills, what I would, that's my thought, that maybe in the bachelor session, maybe in second year, I think, if I remember, we had a course on C, the basic C. But what I would recommend is, in addition to this softwares of, let's say, C, an engineer always, to me, is, what I see is a logical person. He can understand, even without knowing the script, he can understand the logic, how the program is scripted. So I would recommend that we need to emphasize more on educating the people on understanding the logic. Once the logic is there with the person, then what we need to do is, we need to do a separate course in the education, where in which they can explore their skills on programming and its application to various softwares. So I think most of the colleges, I'm sure that we would be using STAD Pro. So if we have the programming, and let's say in addition to C, we also educate them in Excel VBA as one of the primary course, then that becomes an opportunity for them to also know the Excel software plus the programming in Excel, and then afterwards to connect that to STAD Pro itself. So I would say, in the initial years of the bachelor's study, if we could inculcate much more emphasis on the softwares, and also at the same time how the programming can be, linked to various platforms, I think that would be the best way to see how things can be developed.
Yes, sir. One more question, sir. Generative AI is also being applied in design. Could you please share some insights on that area?
Yeah, this basic question, actually, if I see, it's linked mainly to the architectural setups, like for example, where we come up with any kind of geometry. Where I have seen is that they try to even use this topology optimization, which even uses this generative AI to be applied, so that it gives an insight as to what material percentage can be optimized and used. So this is the field, one of the fields I have seen.
Sir, one more question, sir.
Yeah.
Can BIM models be connected to cloud-based project management tools for real-time data updates?
Okay, that's a very good insight what you have asked. Right now, if you see the industry that I'm working in, like, we of course have a shared platform, but it has a restricted access. Not that in cloud, because some industries have this information sensitive, they cannot be shared to everyone. So what we do is, we have a SharePoint which is having a restrictive access, and it's in that SharePoint where we try to dump the data, where in which the relevant stakeholders can access the cloud-based project management tools. But it's not in the public domain, but it's project specific. Yes, so we do connect into specific cloud-based environments.
One more question, sir. How digital twins works?
Yeah, so especially, like for example, nuclear power plants, what we do is, we try to gather the database which is available in already done designs, and we try to connect them in the form of a database. So any kind of new project which is upcoming, so the idea is here not to do a new design. With the already available database in the form of a digital data, with the previous projects, we try to replicate and generate a new model, which is not a kind of new model, but it's a replication of the previous projects. That is where actually the digital twins help in building up not only the design, but also on the real-time data updates.
Sir, one more question, sir. Is possible Python programming is used for analysis of RCC structural elements?
Python programming?
Yes, sir.
Oh, yes, definitely. It's not that just Excel is used. I myself use Python for designing structural elements, be it steel or concrete. So yes, it's definitely yes. It's very much useful. In fact, I would say, like, the latest trends in the past 5 years, Python has taken a major sweep, and also it has gone beyond Excel. But as I said, if you learn one software, I think the logic remains the same. and it's very easy to even extrapolate to Python. It's just the syntax which we need to do.
Thank you very much, sir, for the wonderful session. We are grateful for the time and effort you took to share your expertise and perspectives with us. I am sure the participants have gained valuable knowledge and inspiration from your session. On behalf of the organizing team and all the participants, we extend our heartfelt thanks to you once again for this informative and thought-provoking presentation. Thank you very much, sir.
Hey, thanks to you as well, madam, and
For
all the
accepting our
organization.
invitation and sharing a valuable, informative session, sir.
Yes. Thanks a lot, even for all the participants who have joined, and thanks for the organizing committee as well. My pleasure indeed.
Thank you, sir.
Thank you.
With this, we conclude today's day one session of our ALCTE ATAL Faculty Development Program. We sincerely thank our esteemed resource persons and all participants for the active involvement throughout the day. Participants are kindly requested to fill out the feedback form for today's session. So feedback link is given in your chat box as well as in the WhatsApp group. So the feedback link will be opened till tomorrow morning. Thank you. The ATAL FDP will resume tomorrow with the day 2 session featuring more enriching lectures and discussions. Thank you all. Have a wonderful evening.
Thank you, ma'am.